Assalamualaikum and hi, you are with me again, Miss Huda.
In this recorded video, we're going to learn on the shear force and bending moment diagram. Example number 1. The diagram shows load carried by a beam. Calculate the maximum shear force and bending moment using graphical and sectional cut method. When you get a question like this, you know that you must start off with calculating the reaction at both support. After that, you can draw the shear force and bending moment diagram. And lastly, you can get the maximum shear force and bending moment. I will start using the graphical method first. In the graphical method or any method, the first thing that you need to do is to find the reaction at both support. Here we have pin support or hinge at A and roller support at B. The reaction here is going to be horizontal and vertical.
And for B, it's going to be vertical reaction.
You can start using the moment equation or the force equation, doesn't matter. But I will start with the Fx first because there is no other horizontal forces acting on the beam, which means that the Rax is equal to 0. Next, I can find the value of Ray by taking the moment at B. Okay, sebab kat sini lah support kita, another support that we have, then take the moment over there. Total moment at B is equal to 0, meaning equilibrium. Then what else do we have? Rax dah jadi kosong di sini. Right, Ray going to the B. Okay, so it is clockwise, meaning positive. Ray times 10 meter distance to B. Next, you have 5 kilonewton. The load going to B. It is counterclockwise, therefore it is negative, times 7 meter, the distance to B. Next, 5 kilonewton to B. It is counterclockwise, negative, and times with 3 meter distance. 3 meter here, equal to 0. Yang usually I buat like in our previous example, what I always do in the principles of moment, if you still remember, clockwise equal to counterclockwise. Actually, you will get the same answer here. Ray, which is the clockwise dulu yang kita kira, 7 meter, right? And what else do you have? Okay, equal to 5 kilonewton because this one is counterclockwise, 7 meter, and plus 5 times 3 meter. Sama saja macam ini. Okay, cuma this one dia negatif kat sebelah sini. So kalau you move it to the right, you will get the same equation as this one. The origin of this equation actually dia macam ini. Okay, so ini simplified version lah. Yang actually senang lagi kita nak kenal dia negatif, dia positif, dia kalau dia counterclockwise duduk belah kanan. Kalau dia clockwise duduk belah kiri. Ini adalah simplified version, but actually you will get the same answer, which is Ray equal to 5 kilonewton once you calculate everything. Next, we're going to calculate for the force equation because we have another one, the unknown here, which is Rby. Total force vertically is 0. You have one force going up, Ray, one force going down, 5 kilonewton negative, minus 5 kilonewton negative, since dia turun bawah, and plus Rby is going up. I assume dia akan naik atas, so saya letak plus here, equal to 0. Okay, so 5 kilonewton minus 10 kilonewton plus Rby equal to 0. And you simplify, then you get the final answer. It is 5 kilonewton. Actually, If I use the simplified version, so force going up equal to force going down, you have RAY plus RBY going up equal to 5 kilonewton the load and 5 kilonewton the load. You will actually get the same answer here. 5 kilonewton plus RBY equal to 10 kilonewton and RBY will be equal to 5 kilonewton. Simplified version from this one Sebab dekat sini kita tak separatekan dia, whatever yang arah bawah, okay, semua kita tulis the equation belah kiri and it will be equal to 0 because sebenarnya kat sini kita show lah dia adalah equilibrium sama dengan kosong because dia kata force vertically adalah sama dengan kosong, equilibrium. So semua force yang vertical equilibrium sama dengan kosong. We are done with the reactions at the support. We can draw the shear force and bending moment diagram. From the free body diagram, you insert lah berapa reactions that you dapat. Okay. Horizontal force here, RAX, kalau you tak letak pun tak apa. Sebab dia memang kosong. Tak ada direction pun actually and there is no value. Right, after that, you have to draw the line. So at each point that there is forces along the length of the beam, you have to draw the line. Over here, I have at this point, this point, this point, and this point. That's why you have 4 lines below. Because we will draw the shear force and bending moment kat bawah ni. Okay. Here I will draw the shear force here at this line and BMD at this line. I will call apa-apa yang dekat atas adalah positif and bawah ni positif. BMD pun sama, apa di atas positif, bawah ini negatif. Okay. Saya akan start draw SFD dulu. You have to look at the very far left, okay, paling hujung belah kiri, you have one force which is 5 kilonewton. It is upward. Meaning when it goes up, you akan start macam mana pun when you draw, you will start with 0. Dia naik atas 5 kilonewton, then you akan 0 plus 5. Naik atas positive, become 5. And then you tengok dekat here, there is no load along 3 meter length of the beam. When there is no load, meaning it will go straight. At the second line here, you see there is a 5 kilonewton load going down. Okay, it's a downward load, meaning that you have to minus 5 kilonewton minus 5 kilonewton, dia akan jadi kosong balik. Right? Okay. After that, there is no load at all for 4 meter length. Jadi this goes straight line sahaja. And you see another 5 kilonewton on the third line, meaning you have to minus. Sebab force tu turun ke bawah, kena minus lah. 5 kilonewton. So 0 minus 5 kilonewton, it becomes negative 5. And for the next 3 meter, there is no load, then it becomes a straight line. And finally, the 5 kilonewton at point B, RBY here, it is going up, meaning negative 5 plus 5, it will be equal to 0. After we are done with SFD, we're going to draw for the BMD. In order to draw for BMD, you have to find the area of each rectangle or any shapes that you see in shear force diagram. Over here, I have 2 rectangles. So I put here rectangle 1 and rectangle number 2. So rectangle number 1, it is 3 meter, the width, okay, and the height is 5 kilonewton. You can calculate the area by just 5 kilonewton times 3 meter. become 15 kilonewton meter. And another rectangle, number 2. Sama juga, okay. You can put negative 5 kilonewton, tak salah. And 3 meter. The area going to be negative 5 kilonewton times 3 meter equal to negative 15 kilonewton meter. Zero, kalau you tak letak negatif tak salah as long as you can identify the area is below zero. Okay, di bawah kosong meaning that dia akan jadi area dia negatif. Same goes with the BMD. Okay, we will start with zero. On the first line. Okay, memang akan start dengan kosong sebab tak ada moment, tak ada area lagi kat first line tu. Jadi kita akan start dengan kosong. For the next line, the second line here, okay, kita dah lepas the area number 1. Which is area number 1 is 15 kilonewton meter. It is positive, should be it is above 0. Meaning you just tanda 15 di situ. Dan buat garisan, okay, to connect from the first line sampai second line. There is no area, okay, along this 4 meter. Tak ada area sebab you punya SFD kosong masa tu. Then it will go straight. And for the second area here, okay, for that along the 3 meter line itu, the area is negative 15 kilonewton meter. Ataupun if you write it as 15 kilonewton meter, as you can see, the area is below zero of SFT. Maksudnya you have to minus. Okay, so 15 kilonewton meter, if you write it, okay, if you trying to calculate, plus negative 15 kilonewton meter lah. Meaning you tolak dia akan jadi kosong balik. Bila you end with 0, this is in the state of equilibrium. So if you calculate for SFD or BMD, you tak dapat akhirnya kosong, meaning that perhaps when you calculate for reaction or during the calculation for the SFD and BMD in this graphical method, there is some error. That's why you don't get 0 at the end, sebab dia dalam equilibrium. The question asks you to find the shear force and bending moment, the maximum value. You look at your diagram. For shear force, the highest value would be 5 positive and negative 5 negative. For bending moment, it is 15. Therefore, you ignore lah negative 5 tu sebab sama je. It is 5 kilonewton and the maximum bending moment is 15 kilonewton meter. That's it. Graphical method is much simpler. And for the next method that we're going to learn is sectional cut method. For sectional cut method, the way that you find the reaction sama saja because macam mana pun you nak dapatkan reaction dulu REY, RAX, RBY. Okay, so this one I will skip sebab kita dah dapat reaction in our previous graphical method. You have RAX, RAY, and RBY. Okay. In the sectional cut method, you have to cut it into section. That's why nama dia sectional cut method. Where actually you nak cut dia. Okay, the first one, kita macam mana pun akan start daripada very left here, di sini. Paling kiri. Then you akan tengok saja belah kanan. Okay, before you jumpa another force here, 5 kilonewton, you have to cut it. Okay, kat sini saya potong gambar di bawah ini. You boleh refer. 5 kilonewton, the reaction. Right. And the distance is X meter sebab kita tak tahu distance dia sebelum dia jumpa that 5 kilonewton like exactly before sebelum ni kat sini kita dah potong. So distance dia it is X. Therefore I put X here. And I name this point as C, because ini A, ini B, right? And here I name it as C. When we cut it, there must be a reaction, okay? Reaction, moment, dan force. So force, kita akan ambil dia going down like this. Memang macam tu So you jangan assume dia the other way around. Dia takkan naik atas. Okay, kat sini you tak boleh pakai macam mana cara you nak find the reaction. Masa you nak kira SFD BMD like in a previous, for example, in principle of moment, I cakap kita boleh assume dulu and kita boleh, kalau kita dapat value dia negative, it means that dia the other way around. Right, so for this one, you tak boleh pakai that kind of assumption. We must always assume that the reaction when we cut it for vertical force, shear force here, dia akan go down. And for moment, it will be counterclockwise. So saya tulis kat sini, it is X must be bigger or equal to 0 sebab the section that yang kita calculate sekarang ni, okay, dia adalah mula pada kosong di sini, okay, sampai 3 meter. So sebelum 3 meter kita cut dia, okay, tapi sampai it will be antara kosong ke 3 meter. Kita dah boleh kira dia shear force and moment reaction from our beam yang kita cut itu. For vertical force ataupun shear force V, okay, so kita akan kira dulu. So total moment at Fy is equal to 0. So we have one force going up, so 5 kilonewton positive, and our vertical force here ataupun shear force, it is going down, meaning dia akan jadi negative. Negative and sama dengan kosong. So V adalah sama dengan 5 kilonewton. Jadi memang kita tak akan assume dia naik atas takkan. Ya, ada sebab dia, sebab nanti kita akan tengoklah. Kalau you assume dia naik atas, you won't get the answer Another one we have to do is sebab kita nak cari M, which is the moment. So M, we're going to take M dekat point C here. 5 kilonewton pergi ke C, it is clockwise, therefore it is positive. And X meter distance, sebab force mesti darab distance baru jadi moment. So this is force and distance. And there is no other moment or forces acting on the beam at this section that we cut. So the last one adalah moment ini. Rules dia, kita buat dia counter clockwise, meaning it is negative M equal to 0. Simplify the equation, leave the X sebab kita bukan exactly nakkan mesti ada value. Okay, sebenarnya sebab kita boleh tengok. Kalau kita potong dia, okay, along this kosong sampai 3 meter, you boleh dapatkan value moment ni macam mana? So 5, contohnya you nak ambil dekat 2 meter. You masukkan sajalah 5, 2 kilonewton meter. Masukkan value of X tu adalah 2 meter. You akan dapat 10 kilonewton meter. Itu adalah moment dekat point yang kita nak, which is point X sama dengan 2. Kalau you nak masa point X sama dengan 3, ini distance dekat point ini, masukkan saja 5 darab 3. Jadi 15 kilonewton meter. That is the value of moment. As long as dia berada dalam ini. Okay, dia must be obeying this limit. We have to cut another section lagi because we have that 5 kilonewton loading, the other one. Right, so before kita jumpa that 5 kilonewton, kita cut dulu sini. So when you cut, it is as what I draw below here. Di sini you cut, then I name this as D. Tadi kat sini namakan D. And at this point, it is antara ini X mesti lebih besar daripada 3 meter. Maksudnya X kosong kat sini sampai sini adalah 10 meter. Okay. Sini 3 meter. Sini 7 meter. Dan seterusnya 10 meter. Yang dia tengah nak buat ni adalah untuk section tengah. Right? That's why X mesti lebih besar daripada 3 meter but must be less or equal to 7 meter. Dia punya limit Sama juga, okay, you just draw the free body diagram and according to the sectional cut. So, I just put the 5 kilonewton. 5 kilonewton ni masih wujud. Okay, and kita cut dia sebelum 5, meaning yang ini tak ada lah, tak termasuk dalam our calculation. And that 5 kilonewton dia sampai 3 meter saja di sini. Right? And this distance sampai like previous yang kita cut ni, kita tak ada value, so we put it as X meter. Berapa distance dia, we leave it like that. But we know that X tu adalah mesti lebih besar atau sama dengan 3 ataupun lebih kecil atau sama dengan 7. I'll start calculating the V first using the force equation. So total force Ry is equal to 0. We have one force going up here, so 5 kilonewton minus 5 kilonewton, dia turun ke bawah jadi tolak. And we have the V yang memang kita take it will go down, so direction dia, so dia akan jadi minus V equal to 0. So V adalah sama dengan kosong. And for moment, we have 5 kilonewton. Kita akan ambil dia ke arah D. 5 kilonewton pergi ke D. It is clockwise, positive. Darab dengan X meter. Nak ke D. And we have another 5 kilonewton. The load here pergi ke D. Counterclockwise, negative. And the distance bukan X meter sebab distance dia dari sini sampai sini. Jadi total panjang ini adalah X meter. You tak boleh include dengan this 3 meter sebab distance dia kat sini je you nak yang I buat tanda soal ini. So meaning X meter minus 3 meter, dan itulah distance dia. And another one that we have adalah the moment reaction, which is memang counterclockwise according to what I draw here. So it is minus M. Then you simplify, you will get M sama dengan 15 kilonewton meter. Tak ada dalam sebutan X dekat sini, it's okay. Biar je itu bukan sebab salah. Are we done? Not yet. We have another section that we need to cut, which is before the 5 kilonewton RBY itu. Okay, kalau di sini adalah D, tadi kat sini C kan. Kat sini I put it as E. Di sinilah, okay. E. And when I cut it, okay, I put here the X limitation, it must be bigger or equal to 7 meter. 10, kosong, 7, 3. Dan border pun sebenarnya 3 tu. Okay, so inilah the limit kat sini saja. Meaning that X mesti lagi besar daripada 7 meter but must be less or equal to 10 meter. So you just draw the section that you going to calculate and put the reaction. Sama juga, V will go down and moment will go counterclockwise. And label the distance, which is 1 you have for 5 kilonewton 3 meter, 5 another 5 kilonewton 4 meter, and from the left here nak ke E adalah X meter. I will calculate the force first, okay, using the force equation. So total force arah Y adalah sama dengan kosong, and we have force going up, right, positive. You have 5 kilonewton force going down, negative. 5 kilonewton force going down, negative. And one reaction, which is the shear force V, arah bawah, negatif, sama dengan kosong. Then we get the value of V adalah sama dengan
Negatif 5.
you get here negative. That's why when I say that you have to stick with the V kena turun bawah dan moment kena counterclockwise. Because of this value, it doesn't mean that you will go the other way around. Ini memang jawapan dia. So that's why you have to just use the sign convention. Macam saya tunjuk ini, meaning that when I say the V kena turun bawah like this, and moment is counterclockwise. Ini tak bermaksud dia akan pergi arah lawan. Maksudnya bukannya you assume dia turun bawah, oh sebenarnya dia naik atas. Tak Bukan. So that's why stick to it. So biar je dia negative 5 km sebab itulah jawapan dia. Nanti when we draw the SFT and BMD, we going to take that negative value. Maksudnya dia duduk bawah kosong bila kita draw the shear force diagram. For a moment, I am here that we're going to find the reaction. So if we take the moment at point E, dekat yang mana area kita cut itu, right? And then we have 5 kilonewton force pergi ke point E ialah positif. Darab dengan X meter, force darab distance, X meter distance. Next you have 5 kilonewton going to E. It is counterclockwise, negative. And the distance is X tolak 3 meter. Sebab distance ini saja yang you nak. Okay, so maksudnya kalau panjang beam ni adalah X meter, you have to minus dengan 3 meter di sini. Right, so kita akan dapat value sebelah dia. And another one, we have 5 kilonewton nak pergi ke E. Sama juga, okay, sebab you nakkan distance ini saja. Right, so kalau panjang dari sini sampai sini ada 7 meter. So X kena minus 7 meter baru dapat berapa tanda soal ini. So simplifykan your calculation, right? So kalau you rasa you confused macam mana you kena darab bila ada dalam kurungan macam tu, meaning that 5 km kena darab X meter. So jadilah ini. Ini darab ini dan ini. Okay, jangan lupa ni negatif. Negatif 5 km darab negatif 3 meter. Then you get positif. Okay, negatif dan negatif jadi positif. So it is 15 kilonewton meter. Sama juga dengan this one. Negatif 5 kilonewton darab dengan X meter jadi 5X kilonewton meter. Negatif. And negatif 5 kilonewton darab negatif 7 meter dia jadi positif 35 kilonewton meter. Right, so simplify everything. Then you akan dapat dalam bentuk macam ini. X2 leave it like that because kita akan gunakan berapa panjang dia tu using ini. Limit dia kat sini. So X2 mesti value dia lagi besar daripada 7. X ini mesti lagi besar daripada 7 atau sama dengan 7 ke lagi kecil daripada 10 atau sama dengan 10. Tak boleh lagi besar daripada 10. Beam you pun sampai 10 meter je. Kita dah ada semua equation. So what I do next when I want to draw it is much easier for you. Like me here, I akan ambil semua value yang bawah ni. Okay, so I will start with this one. This is the first one. X mesti lebih besar daripada atau sama dengan kosong. Smaller or equal to 3 meter. I take this value and I take this value. And for this limit, okay, I take this value and this value. And for this limit, I will take this value and this value. Here is the SFD again, right? So you, as usual, you have to draw that 4 lines because we have 4 points yang ada load. SFD and BMD, right? So kita akan start dengan this limit first, okay? Start daripada kosong. So I akan buat SFD dulu, which is X lebih besar daripada atau sama dengan kosong, or X is less or equal to 3 meter. V sama dengan 5 kilonewton bila berada dalam limit ini. Okay, tengok balik equation yang you buat sebelum ni. So, bila V sama dengan 5 kilonewton, so you tahu 5 sepanjang ini dia tak berubah. Maksudnya daripada limit kosong sampai 3 meter ni V adalah 5 kilonewton. So 5 sampai sini 5. So straight dia pergi. For the next 4 meter tu, okay, ini adalah limit dia. Okay. X must be bigger or equal to 3 meter but less or equal to 7 meter. Meaning dari sini sampai sini, okay, we get V equal to 0. So dia jadi satu straight line sahaja. Memang sepanjang line tu, that is the value. V adalah kosong. And for another limit, which is the last one, di sini, okay, sebab X is more than or equal to 7 meter and less or equal to 10 meter. Berada di sinilah. And we get that V is negative 5. So terus tanda dia negative 5. That's why I said bila you dapat V here, you dapat value dia negative, it doesn't mean that you salah arah. Memang value dia ini sebab sekarang you tengah lukis the SFD. Okay, that's the reason why you have to follow. Kalau V must always like this, and moment you go counter clockwise. Tada! So kita dah dapat kita punya shear force diagram. So sama tak this one dengan like the previous graphical method? Although graphical method it is much easier, okay, tapi the sectional cut method ini lebih precise. Maksudnya kita boleh senang lagi buat beam analysis. Sebab kita boleh ambil untuk setiap points. Kita ada the equation. So you just take, okay, you nak analyse dekat point X sama dengan 7 meter for example. So you boleh ambil 7 meter, masukkan dalam equation dan you boleh dapat the exact value of that point. Okay, compared to the graphical method, okay, there is some certain circumstances yang you tak dapat cari. Okay, itu kita akan tengok masa bila sebenarnya yang kita tak dapat cari. Kalau kita pakai the graphical method. Kita boleh buat the bending moment diagram. Right, so this is moment equation yang kita ambil daripada our previous calculation, which is M is equal to 5x kilonewton meter. Okay, so you ada 4 lines here, and sekarang our main line yang kita concern adalah line ini dan line ini, sebab 0 sampai 3 meter. 3 ni kosong. So you masukkan je 5x kilonewton meter ni. Okay, masukkan value x. The first line, the first force kat sini adalah bila 0 meter. So 5 darab 0 adalah 0. Meaning dia akan start 0. Right, so another one, another line here is 3 meter. That is our limit kat sini. Okay, sama dengan ataupun smaller than 3 meter. It is sama dengan Okay, therefore you masukkan 3 meter dalam ini. So 5 darab 3 kilonewton meter. So become 15. Okay, positif. So maksudnya dia ke atas. Macam itulah. Itu saya letak fit 15. Dan you tahu you kena buat garisan. Okay, limit dia X is bigger or equal to 3 meter but less or equal to 7 meter. Meaning di tengah-tengah ini, M sama dengan 15 kilonewton meter. Okay, dia tak ada X kat sini, meaning dia tak berubah. So, sepanjang X bigger or equal to 3 meter, less or equal to 7 meter tu, sepanjang that limit dia adalah 15 kilonewton meter. Therefore, buat je straight line. Last kali, our limitation here, 7 meter. Okay, X must be more or equal to 7 meter, less or equal to 10 meter. Di sinilah untuk ini area ini. The equation is 50 kilonewton meter tolak dengan 5x kilonewton meter. So the first line kat sini kita nak check saja sebab sebenarnya memang 15 tapi mungkin dia berubah. Kita tak tahu so kita masukkan dia. 50 kilonewton meter tolak 5 darab. Bila X sama dengan 7 kat sini 7 meter limit dia ni. Masukkan limit dia. 7 meter. Then you akan dapat jawapan dia adalah 15. Maksudnya betul tak? Memang 15 dekat sini. 5 darab 7, 35. 50 tolak 35, 15. Right. And last kali, you akan masukkan bila X sama dengan 10 meter. Tadi kita buat X sama 7 meter di sini. X sama dengan 10 meter. M sama dengan 50 kilonewton meter minus 5 times 10, which is 10 meter, kilonewton meter. So, you akan dapat kosong. So, betul lah dia akan berakhir dengan kosong. So, sama tak dengan the graphical method? Sama. You will get the same answer, but the sectional cut method is a bit susah sikit sebab you kena cut to sections and you will actually get the actual value yang you boleh buat. Masukkan je value X if it's needed. But sectional cut, it is much berguna kalau you buat beam analysis. For example, kalau you ada uniformly distributed load. Uniformly distributed load, yes, jawapan dia kalau you kira pakai the graphical method, it won't be that precise lah. Okay, maksudnya you tak dapat kaji betul-betul berapa value untuk setiap, for example, X sama dengan 10 meter. Tak dapat betul-betul kaji berapa sebenarnya value dekat that point. While the sectional cut, if you need to find the specific point punya value, you boleh dapatkan value-nya. Kita dapatkan the maximum shear force, it is 5 kilonewton. Or this one, right? And the maximum bending moment adalah 15 kilonewton meter. Sama je. Okay, so we are done with example number 1. See you in example number 2.